Welcome back for another deep dive. This time, we're taking a look at large language models, or LLMs, and how they might be able to, well, change software engineering.
It really is a fascinating topic, especially with all this new research coming out.
Yeah, and for this deep dive, we're going to be focusing on a bachelor's thesis from the Technical University of Berlin.
A really interesting one, too.
Yeah, it's all about testing GPT-4 and seeing if it can actually automate some of the tasks that software engineers do, like building and testing software.
And spoiler alert, the results are kind of a mixed bag.
Yeah, definitely not a simple yes or no answer.
One of the coolest things about this thesis is that they actually put GPT-4 to work on a real open source project called GitLab-Calendar.
Oh yeah, GitLab-Calendar. I think I've heard of that one before.
You probably have, it's quite popular.
It's that tool that lets you create calendar files from GitLab issues, right?
Exactly. And the researcher picked it specifically because it already has a solid CI/CD pipeline and tests in place.
So they could really compare what GPT-4 came up with to a real-world example.
Yes, exactly. It's a great way to benchmark GPT-4's performance against what actual developers have built.
That makes a lot of sense. But before we go any further, could you maybe give us a quick rundown of what LLMs are and what makes them so special, for those of us who might not be total AI experts?
Sure thing. Basically, an LLM is like a super powerful language whiz.
Mhm.
You can understand and generate human-like text and even code.
Wow. So it can write code on its own.
In a way, yeah. It's been trained on massive amounts of data, so it can do some pretty incredible things like translate languages, write different kinds of creative content, and even answer really complicated questions.
So some examples would be like GPT-3 or GPT-4 or
Yeah, those are some of the big names you've probably heard of. Also,
uh,
Polem and
route.
Olema.
Right, right.
So,
So theoretically, if I gave an LLM a bunch of code and asked it to write some tests, it could actually do it.
well, theoretically, yes,
Okay.
but it's not quite as simple as just giving it a command. It's all about how you give it those instructions. It's called prompt engineering.
Prompt engineering. So it's like giving the LLM a super detailed recipe for the code it needs to create.
Yeah, that's a great analogy. The clearer and more specific your instructions are, the better the output you'll get from the LLM.
So it's kind of like working with a really talented, but maybe a little bit literal-minded assistant.
Exactly. You need to be very precise in how you communicate with it.
Okay, so we've got GPT-4, LLM star, and we're giving it a real project to work with, but there's also this whole other piece, right? The DLR software engineering guidelines.
Right. The researcher wanted to see if GPT-4 could produce code that met the standards of professional software engineers. So they used these guidelines from the German Aerospace Center, or DLR, as the benchmark.
So these guidelines are kind of like the gold standard for software development.
Pretty much. They focus on automation, making sure different software components work together smoothly, and really rigorous testing.
Okay, so the challenge is set. GPT-4 has the DLR guidelines, and it's time to tackle the GitLab-Calendar project. What was the first task they gave it?
The first thing the researcher did was ask GPT-4 to create a CI/CD pipeline for the project from scratch. And believe it or not, it actually managed to create a pipeline with the correct stages: build, test, and release.
Wow, that's pretty impressive. So it sounds like GPT-4 has a good grasp of the basics of software development.
Yeah, it really does. But there's a bit more to the story.
I have a feeling there might be.
While the overall structure of the pipeline was correct, GPT-4 makes some pretty significant errors.
Oh no, like what?
For example, it completely forgot to define the Python environment needed to run the code.
Oh, that's kind of important.
Yeah, kind of a big deal. And then it kept referencing a file called requirements.txt that didn't even exist in the project.
So it's like GPT-4 got the big picture but totally fumbled the details. Why would it miss something as crucial as the Python environment?
Well, that's one of the key questions the thesis tries to answer. It suggests that this might be a blind spot in how LLMs are trained. They've seen tons of code, but they don't always pick up on the underlying assumptions or dependencies that would be obvious to a human developer.
So it's like they've learned the grammar of a language without really understanding the culture and context.
That's a great way to put it, and it highlights a key takeaway from this research. LLMs are powerful tools, but they're not perfect.
Definitely need a human to double check their work.
Absolutely.
Okay, so GPT-4 had some trouble with the CI/CD pipeline, but it still managed to create something that kind of worked. What about software testing? Could it write good tests?
That's where we'll pick up in the next part of our deep dive. The researcher put GPT-4's testing skills to the test, and the results are just as interesting.
Can't wait to hear about it. All right, so we're back and ready to dive into the software testing part of this deep dive.
Yeah, this is where it gets really interesting.
Definitely more complex than just setting up a pipeline, I would imagine.
Oh, absolutely. So the researcher had GPT-4 try to write a test .gitcalendar.py file.
So basically writing the tests for the GitLab Calendar project.
Exactly. And they made sure that GPT-4 followed those strict DLR guidelines we talked about earlier.
Those super high standards for software engineering.
Yep. And get this, GPT-4 actually managed to create tests that covered some of the core functions of the project. It even used mocking.
Hold on, mocking. What's that?
Good question. So let's say you've got some code that relies on an external API, like something that fetches data from a weather service.
Okay, I'm following.
Now, when you're testing your code, you don't want your tests to actually depend on that live API.
Right, because what if the weather service is down or something?
Exactly. So you use mocking to basically create a fake version of that API.
So it acts like the real thing, but it's controlled and predictable?
Exactly. And that way you can isolate and test your own code without worrying about external factors.
That's pretty clever. And GPT-4 knew to do this on its own.
It did,
Wow.
which is pretty impressive on the surface. I mean, it shows that GPT-4 has been exposed to all sorts of testing techniques and can actually apply them correctly.
But I have a feeling there's a but coming.
You know me too well. There's a but.
Okay, lay it on me.
The problem is that those tests GPT-4 wrote were based on a wrong assumption.
Oh. What did it assume?
It assumed that the GitLab Calendar code was structured using classes, but actually it's mainly function-based.
So even though it understood the concept of testing and even knew about advanced techniques like mocking it, still messed up because it didn't really understand the structure of the code.
That's exactly it. And this really highlights a fundamental issue with LLMs right now. They're great at recognizing patterns and copying what they've seen, but they struggle with deep contextual understanding.
It's like they know the words, but not the meaning behind them.
Exactly. They can miss those subtle but super important differences that any human developer would catch right away.
It's almost like if you wrote a screenplay for a film noir, but the director decided to make it a slapstick comedy instead.
That's a great analogy. The script itself might be perfectly fine, but it's totally wrong for the movie.
Right, it just doesn't fit. So do you think this kind of error is something that could be fixed with better training data? Like if LLMs were exposed to more code with different structures, would they make fewer assumptions?
That's a great question, and something researchers are definitely working on.
I bet.
One thought is that the data sets used to train LLMs might be biased towards certain programming styles.
Because they've only seen a limited range of examples.
Exactly. So if GPT-4 was mostly trained on code that uses classes a lot, it might automatically assume that other code is also structured that way, even if it's not.
So it's like if you only ever ate Italian food, you'd think every meal should have pasta.
Exactly. They need a more well-rounded diet of code to learn from.
Makes sense. All this talk about food is making me hungry, but we gotta stay focused.
Right back to the deep dive.
Okay, so it seems like these LLMs are kind of like talented but inexperienced interns. They have potential, but they need a lot of guidance.
Yeah, that's a good way to think about it. And it brings up a really interesting point that the thesis makes. If LLMs need this much supervision, who actually benefits most from using them?
That is an interesting question. I think junior developers would get the most out of having an AI assistant.
You'd think so, right? But the thesis actually suggests that senior developers might benefit more.
Oh, wow. Why is that?
Well, because they're the ones who can actually spot the errors in the LLM's output
Yeah.
and refine the prompts and basically be a good teacher to the AI.
That's true. They'd know when to trust the LLM and when to step in and correct things.
Exactly. And they could also really leverage the LLM's strengths, like generating code quickly and automating those tedious tasks.
It's kind of like having a superpowered apprentice.
Exactly. Someone who can do the heavy lifting, but still needs the master craftsman to guide them and make sure everything meets the highest standards.
Love that analogy. It really highlights this whole idea of humans and AI working together in software development.
Yeah, it's not about replacing humans, but about augmenting our abilities.
Collaboration, not competition.
That's the key. It makes you wonder what the future holds for this human-AI partnership.
Definitely a lot to think about. And that's actually a perfect segue into the final part of our deep dive. We're going to explore some of the thought-provoking questions the thesis raises about the future of LLMs.
Questions that could totally reshape how we build software in the years to come.
I can't wait. All right, we're back for the final part of our LLM deep dive, and I gotta say, my brain is buzzing with questions about the future.
Yeah, after seeing what these LLMs can do and where they still kind of struggle, it's hard not to wonder what's next.
Absolutely. The thesis we've been talking about hinted at some pretty big changes coming down the line. Like, what if we completely changed how we interact with these AI tools?
Yeah, that's a really exciting thought. What if instead of just giving an LLM a prompt and crossing our fingers, we could actually have a back and forth conversation with it?
So instead of it being like a one and done kind of deal, we'd actually be working side by side with the LLM throughout the whole process.
You got it. Imagine being able to ask the LLM questions like, hey, why'd you write the code that way? Or can you walk me through your logic? Or even just, hey, let's tackle this tricky part together step by step.
That would be amazing. It'd be like having an AI pair programming partner.
Exactly. And think about all the benefits of that. Not just getting the code written, but actually understanding the problem better, maybe even coming up with solutions we wouldn't have thought of on our own.
I love those aha moments when you're working with another developer and suddenly a new approach just clicks into place. Now imagine getting that spark of insight from an AI.
Mind-blowing, right? It's like tapping into this massive well of knowledge and problem-solving skills, but in a way that feels much more collaborative.
Totally. So this idea of having a more conversational back and forth with LLMs, it's not just a fantasy then.
Not at all. Researchers are already working on making this a reality. It could be the key to really integrating LLMs into the way we build software.
Wow, so we could really be blurring the lines between human and AI capabilities.
Exactly, working together to achieve something truly remarkable.
That's incredible. The thesis also talked about this other really interesting concept specialization. Right now, we're using these general purpose LLMs for basically everything. But what if we had models specifically trained for certain tasks in software engineering?
That's another huge area of potential. Imagine instead of one giant LLM trying to do it all, we had a bunch of specialized models, each one a master of its own domain.
So like one for building CI/CD pipelines, one for writing unit tests, one for refactoring code, one for security analysis.
Exactly. It would be like having a whole team of AI experts ready to jump in and help with whatever you need.
That would be a game changer, especially for smaller teams or startups that don't have a ton of resources.
Absolutely. And as we learn more about how LLMs are actually being used in the real world, we can figure out which tasks would benefit the most from specialization.
It's kind of like how medicine has evolved over time, right? We went from general practitioners to having specialists for every part of the body, every condition.
It's a natural progression. And it makes perfect sense in the world of AI and software engineering too.
It's all about harnessing the power of AI in a more focused and efficient way.
Right, using the right tool for the right job.
Makes sense. So looking ahead, imagine an LLM that not only writes code, but can actually predict potential bugs before they happen, or suggest optimizations that we humans might miss.
That's the kind of future we're talking about. A future where humans and AI work together seamlessly, each playing to their strengths, pushing the limits of what's possible in software development.
This deep dive has been eye-opening. We started with the simple question, can LLMs help us build software? And we've uncovered a whole universe of possibilities, challenges, and exciting advancements.
And the journey doesn't end here.
Yeah.
This is just the beginning. The future of software development is literally being written as we speak.
And that's what makes it so exciting.
Absolutely.
Yeah.
So to everyone listening, keep exploring, keep asking questions, and keep pushing the boundaries of what we can achieve with these amazing AI tools.
The future of software development is collaborative, it's full of potential, and who knows, maybe you'll be the one to write the next chapter.
We can't wait to see what you come up with.